So now that we know a little bit about fractions and how they work and how to compare them, we can start doing operations on them. So we are going to add and subtract them. The methods for adding and subtracting are going to be the same. We really need to care whether we have like denominators or unlike denominators. And here the like denominators were where we would start when we were teaching. So these are when we have the same denominator. So maybe my denominators are both b. In that case, I just have to add the numerators together or subtract. It would be the same for adding or subtracting. We do not add the denominators together. So notice that just stayed b. We just add the numerators together. So for instance here, I'm going to kind of draw a picture to go with this. I'm going to add together 2 different eighths. So let's say I were to add 1/8 plus 5/8. So 1/8 would be one of these shaded, and 5/8 would be 5 of them shaded. So the reason I don't add the denominators together is because you can think about taking those pieces together of like our pie here or our puzzle, or our pizza, sorry. And if I imagine putting them together, the circle's a little too big. Let me make a smaller one because we do want our area models to be the same size. So that's closer to the same size. That's still not that great looking. Let me try one more time. There we go. I can imagine taking these pieces and putting them on the same pie. It's still split into 8 slices, but now I have 6/8. Of course, we would want to reduce this down. I'm going to leave it as the 6/8 so we can see that we keep the same denominator. This usually goes pretty well until we introduce multiplication and division in the next section, in which we kind of change what we do with those denominators. But the reason we keep it the same is because we can think about just combining them together. Our pizza there is still split into 8 sections total. Now, since we do have to keep the denominators the same, we can't really add them if they have unlike denominators. We have to get that common denominator. So for instance, I'll give us a problem to start with, and then I'll write up in my variable form what would happen. If I had like 2/7 plus 1/3, I can't add the 7 and the sevenths and the thirds together because they don't have a common denominator. So I need to get a common denominator. It doesn't have to be the least common denominator. It could be. I'll do the least common denominator now, but it could be any denominator. So the least common denominator would be 21. 7 times 3 is 21. They're both prime numbers. So I can do that multiplication, and that will always give me the least common denominator. So to get the 1/3 to have 21 in the denominator, I have to multiply by 7. To get the 2/7, I would have to multiply by 3. So that would change this problem to 6/21 plus 7/21. So my answer would be 13/21. So what I did was I changed this 2/7 into 6/21 and the 1/3 into 7/21. So I changed them so they had the same denominators, and then I could add them together. So if I were to write that up like I did up above, I would have 2 different denominators there, b and d. So what I did was I multiplied, in this case I had b, I multiplied this other side by b. And what was d, I multiplied that other numerator by d. So writing that up, if b was 7, then I multiplied c times b, and I also multiplied b times d on the bottom there. Let me do one more of these. I'll do it with variables this time. Let's try. So let's try 3/x² plus, and I'll do a -5/y. Just throw in there, we can do this with integers. So in this case, c would be -5. So we could do it with integers. It doesn't have to be with whole numbers. My least common denominator in this problem would be x squared over y. So this first fraction is missing the y, so I'd multiply by y. The second fraction, put the multiplication sign on the wrong part. There we go. The second fraction is missing the x squared, so I'd multiply by x squared. So that would leave me with 3y in the first fraction and negative 5x squared in the second fraction. And now I can combine those numerators and the denominator just becomes that LCD. I like to write these out, these LCDs, as you see I have written there. That way I know the goal. If I write that on the paper, that helps me see what I need the denominators to be. Sometimes when we keep too much in our head, we're not sure what to multiply by. So if you're having a little bit of trouble, what I tell you is don't try to skip too many steps. Just go ahead and write that LCD down there. You can see what your denominator needs to be. Then you can multiply by something to get your denominator to turn into that.